Okay, good afternoon, everyone. So let's discuss how we can quantify the materials needed for masonry unit. So as you can see here, you have here, example, the area of the wall. So you have here the wall. You can just compute the area of the wall by just multiplying this L and then this W, or height, I should say. L times height, okay? L times height. And then we less, or we deduct the area of these windows, or this window and the door. Okay, for if you have, so for example, for exterior wall, in the ground floor you have a number of doors and a number of windows, so you have to deduct all of those opening. So we are going to compute for the number of pieces of CHB. It's just compute the area and then multiply by 13. So this 13 is just actually 12.5. 0.5 might be a factor of safety. This one is being going to use. It's in the module here in FEU. So, for example, you have an area of 100 square meter. You can just simply compute for the number of CHB by multiplying 100 to 13. So this 13 pieces is per square meter, and in other words, in every 1 square meter, there are 13 pieces of CHB. So you can have 1,300 pieces of CHB. Now, let us try this one. Let's say you have floor plan. You have this floor plan. Okay. So you have to first identify what are the opening. So we have window 1, window 2, and window 3. For window 1, there are 2. Okay, 1 and 2. For window 3, no, window 2, there is 1. For window 3, there's also 1. So these sizes could be taken from the plan, of course. It's in the specification. There's the schedule of doors and windows. So this one should be deducted from from the gross area of the wall. So simply getting the total length, let's say we just focus on exterior wall. The total length is, first you have this 1.2. Of course, you should exclude the column, okay? There's the column here. And then you have your 3.75 for this wall. Okay, it should be a clear, okay? Clear width. And then you have another 3.75 as well. And then you have 4.7. It's all clear distance, excluding wall. 0.3, 0.3, and then 0.3, and then 8.05 from here going here. Okay, there's no column here because the column here is inside, and then you have 2.75. So you can get the total length is equal to 25.1 meter. Now you are going to multiply it by the height, then you can get the area of the wall. Now, for example, this is your beam. Okay, so if the total height is 3 meters, let's say this one is 3, and then the thickness is, let us say it's 0.5. So in other words, you have this clear height to be 3 meters minus 0.5, and you have 2.5 meters. Now the gross area of the wall becomes 25.1 times 2.5, you have 62.75. You have to deduct the area of the windows and doors. So you have 1.2 times 1.2 by 2 units for window 1, and then 1 unit for window 2. That is 2 times 1.2. And then 1 unit again for window 3, 1.8 by 1.2. So you have this 7.44 square meter. Okay, so the total net area now is just the gross area, which is 62.75, deducted by the doors and windows. Then you have this net area. Okay, so from here, you can compute now the number of CHB and then the materials included, uh, just like the cement and the sand. So of course, you have the area already. You multiply it by 13, you can get 720 pieces. Now you can use here this 720 pieces to compute for the bags of cement and the bags of the sand. Cubic meter of sand, I should say. So just take note. Wait. Let us just take note that okay, this one is the mortar that you are going to to compute. What is this mortar? This is the mortar. Okay, as you can see, this is the mortar that you're going to fill inside here. Okay, inside the hole, and then between layers of, or in the between blocks. Okay, at this layer. Okay, so from that we can therefore compute the number of bags of cement by just taking this factor. Okay, you have 0.1505 times 720. This one is 720, the number of pieces of blocks. That is if you are going to use class A. So assuming you are going to use class A, then we have this factor. And then sand you have 0.0081 as well, with the 720. Then you have, for the mortar, 109 bags of cement, and then 5.83 cubic meter. Now you can add 10% for the factor of safety. Also here, plus factor of safety, which is 10%. Also a factor of safety, which is 10%. Okay. But you can do it afterwards pagka matapos ng lahat ng calculation nyo. So that you might duplicate the factor of safety that you're going to add. Anyway, just have to think that the factor of safety ranges from 5 to 10%. Actually, that would depend upon the computation of the company. They have their own factor of safety being used. Okay? Kasi pagka magpa-participate ka ng bidding, you make sure na hindi ka lang na makuha mo yung kuwan na masyado malaki din yung mga factors mo. Okay, so let's continue. Now, for the plastering material, you have cement, lime, and then sand. So you need to just get the plastering area. So plastering area, earlier we computed, that is 55.31. This is the area of plastering. You just multiply it by this factor, okay, 0.0082. Using class A. Okay, take note that before we use class A, so we're going to use also class A here. So the area, this one is in terms of the wall area. Here, in terms of the number of pieces of CHB. Okay, take note about these factors. Anyway, it's very clear here. Number of CHB. Here, it's plastering area. So we use this factor 0.082 times the area, which is 55.31. Then you can get the bags of cement. The same factor for this lime, you can have also here. And then for the sand, it's 0.009 for the sand. So you have here 0.5 cubic meter. As I said, there is also factor of safety by which better if you're going to use it, or to sum up first all the number of bags of cement and then volume of sand, and then get the factor of safety later. Okay, then after that, you have the horizontal and vertical reinforcement. For vertical reinforcement, you have this spacing. What is this spacing? 0.4, 0.6, and 0.8. This one, okay? Here. It could be 0.4, it could be 0.6, and it could be 0.8. Horizontal reinforcement, okay? This one is for horizontal reinforcement. This one should be horizontal. It's in layer, 2 layers, 3 layers, or 4 layers. So this one is 2. You have 1, 2. If you have 3 layers, okay, if you have 3 layers, you have 1, and then you have here, okay, this is 3 layers, 1, 2, 3. Now let's say you just have to use 2 layers, okay, and then here use 0.4. So this one you can compute in terms of uh, per block or per square meter, per square meter of the wall. So let's say you use per square meter of the wall, we use 2.93. So the factor is 2.93 multiplied by the area of the wall, which we computed earlier. Then we can compute the length of the vertical reinforcement. This one is 162.06. Now for horizontal reinforcement, we are using at every 2 layers. That is, you're going to check from the specification, from the plan. In the plan, it would state or specify how many layers is the reinforcement bar, or what's the spacing of the vertical bar. It's all in the plan that you can check. So let's say you have these 2 layers, at every 2 layers, so you are going to use 3.3. Okay, then you have 3.3 times the area of the wall, which we calculated earlier. Then we have this 182.5. So therefore, the total length of the reinforcing bar that you are going to have is 182.5, and then 162.06 is equal to 344.56. And then from that, we can now compute the number of pieces of bar. Let us say you're going to have 6 meter length that you're going to buy from the market, from the store. Or you may use also 3 meters. There's also, I think, 7.5. There's 9. So, of course, mas practical yung 6 meters. Madali siyang, hindi siya masyadong mahaba gaya ng 7.5 or 9. Okay? 3 meters, that might be short. You might have more splicing. But 6 meters, I think, is much appropriate. So if you have your the total length that you computed earlier, which is 344.56, just divide it by 6, then we can have 57.43 pieces or 58 pieces. Now, kung magdadagdag ka ng 10% allowance, just like what I have said earlier, it's just 0.1 of 58. 6, that's 10% plus 58, I'll give you 64 pieces of 10 millimeter diameter by 6 meters. Take note, this is just for the ground floor and this is only for the external wall. In other words, you have to compute for your internal wall, and then I don't know with your project, maybe you have second floor, and the actual project you might have third floor, fourth floor, and multi-story for multi-story building. So you have succeeding floors after this. Okay, so at least this is the basic you know concept in how you're going to estimate the materials needed for your masonry unit. Okay, thank you. That's all. If you have a question, just drop your question in inbox.